In this video, we're going to see how to determine if a set of vectors is linearly dependent or linearly independent. So here I have a set of three vectors written down. And our question of if they are linearly dependent or not is really a question of, can we build one of these three vectors out of the other two? So note that another way of saying that is, how many ways do we have to build the zero vector out of these vectors? So how many solutions does the vector equation, say x1 times the first one, 2, 1, negative 1, plus x2 times the second one, 3, 1, 4, plus x3 times the third one, 1, 1, negative 6. How many ways can we produce the zero vector here? So note that whenever we have a non-trivial solution here, so the trivial solution would be when x1, x2, and x3 are all 0. So we can always build a zero vector that way. But if I can do this with one of these x1, x2, x3s being non-zero, then I can rearrange this and solve for one of these vectors in terms of being built out of the other ones. So if we only have the trivial solution, then these vectors are linearly independent. If we have a non-trivial solution, these vectors are linearly dependent. So now we have a vector equation that we can solve. So we'll write down our augmented matrix to go along with this system. 1, 1, 1, 0. All right, and to figure out how many solutions we have, we'll compute the reduced row echelon form of this matrix. So I have gone ahead and typed this into Wolfram Alpha ahead of time. So 1, 0, 2, 0, 0, 1, negative 1, 0, and that last row is 0, 0, 0, 0. All right, so as I said, we always have a solution. The question is if we have one solution or if we have infinitely many solutions. And the key thing that's going to tell us how many solutions we have is whether we have any free variables or not. So whenever we have a free variable, that's going to correspond with infinitely many solutions, because that free variable could take on any real number value. So when I look in here, I see this non-pivot column right here that's going to give us a free variable. And we know that free variable is going to correspond to infinitely many solutions. So in particular, if I have infinitely many solutions, I have non-trivial solutions. If I have non-trivial solutions, so infinitely many non-trivial solutions, that means I'm going to have one where one of these three terms is non-zero, and then I'll be able to solve for that vector in terms of the other ones. So infinitely many non-trivial solutions tells us that we can build one of these three vectors out of the other two. So they are linearly dependent.